So the question we're going to do today is longest consecutive sequence. It is the 9th question of our NeetCode playlist and the 128th question of NeetCode. Now note that this is not LCS. LCS is a DP question which is longest common subsequence. Here it is longest consecutive sequence. So let's go word by word to understand what does the question want. What is a sequence? Let's say we have an array 1, 2, 3 and 4. So a sequence is if we take elements from this array in any order. Let's say we take 1, 4, 3, 2. We got 1, 4, 3, 2, or maybe we got 1, 3, 2, 4, 1, 3, 2, 4. These are sequences. If it was this question, which is longest common subsequence. Subsequence means you can take in any order, but you can take any order elements, but in the same order as the array. Like you can choose to take or not take some element. Let's say I took 3 and 2. So 3, 2. This is a subsequence. But 2, 3. This is not a subsequence because it is the order. The order of the array is not maintained. Subsequence is you can either take an element or not take an element, but the order should be maintained. 3 should come after 4 only. 3 cannot come before 4. But this question says sequence. That means we can take the elements in any order, and that's a sequence. So now let's come to the next word, which is consecutive. That means let's say I have a sequence 2, 4, 6, 8. This is a sequence, not the array. Okay. Let's say there's a big array and we got this sequence from it. So we can see that 2, 4, 5. We can see that there is 3 missing here, and 4, 5, 6, 7 is missing here. So this is not consecutive. Consecutive means each number should come after the previous number in the number line. So for this array, consecutive sequence can be 1, 2, or 1, 2, 3, or 1, 2, 3, 4. These are consecutive sequence because these are sequence and they have the numbers as consecutive numbers. The number line, which is 0, 1, 2, 3, 4, it should be any part of this. Like let's say we take 2, 3, this is a sequence. This is a consecutive sequence. So the number should be next to each other. Now next word is longest. That means out of all the sequences, 1, 2, 1, 2, 3, 2, 3, 3, 4, 2 length, 2 length, 2 length, 2 length, 4 length. That means this is the longest consecutive sequence. So that is what the question is asking. So let's take a good example and solve it. Now let's say let's just erase it. So we have an array that says, let's say 100, 4, 200, 1, 3, 2. So let's just calculate answer ourselves. Then we will see how we will do it in code. So there are 2 sequences here, 100, 200, this one, and 1, 2, 3, and 4. 1, 2, 3, 4. So we can see clearly that this is the final answer. But how to solve it? So the first method will be a brute force, in which we will just do the extreme whatever we can without caring about the time and space complexity. So for each index, we will do one loop. For each number, we will assume that let's say 100 is the starting point of a sequence, which we do not know yet. So we assume 100 is done. Now we check for next elements. So we do one, let's call it a function called check. If we have 100, that means we now want 101. If we can find this in the rest of the array, that means you can add 101 and continue for 102. And if we cannot find it, that means even if we find 102, 103, 104, 105, it doesn't matter because we don't have this one. This one should be 101 only. So let's call this function as check that we wrote here. This function, what this will do is we assume that this is a starting point. Now each time we call this function, it will check the full array for an element. Let's say we go for check 101. If we got this, if we got true, that means 101 is done. So now check for 102. So now we call the function again, check 102, and then again it goes a full loop. It ignores the elements we have already done. If we can find 102, that means 102 is done. Now check for 103 and keep going on until you can't. Let's say we get length 8. So store that in a variable, answer variable 8, as this is the highest we have so far. Earlier we have 0 because no answer, then we have 8. Now we keep doing it. Okay. So let's say first entry is done, 100 is done. We got 100, 200 and nothing else. No, actually no, this is also not valid because this is not consecutive. So we did not get anything. Now we go to 4. Similarly, for 4 we check if there is a 5. There is no 5, so just stop there. So we got only 4, so 1 length. So answer was 0 before, we got 101, then we got 4, again 1 only because there is no better solution yet. Now we come to 200. Again for 200 we find 201 in the array. We cannot find it. No. So again it says 1 only because we have not found anything better. Now for 1 we have to find, is there any 2? 1 full loop, we found 2. So 2 is here. So update the length was 1 before, now the length is 2. And now we have 2, so find 3. 3 is here or not? 3 is here. So now length is 3 because 1 to 3 we have seen so far. Now we check for, is 4 there? So we do one loop again, we found 4. So 4 length we have seen so far. Now we see if there is 5. 5 is not there in the full array. So now we got the max length is 4. Earlier it was 1, so we updated it as 4. Now we check for 3. For 3 we want to find 4, so we got 4. That means 3, 4. But we can find 5. So this is the length of sequence 2, which is not greater than this, so we do not update it. For 2, we check is there 3 here, so 3 is here. Now we check 4, we got 4. So we got 2, 3, 4 sequence because there is no 5. Sequence length is 3, but it is still not better than this, so the answer is 4. So what did we do in this question? We did one loop for each starting index element, we assume, and for each element we do a lot of loops to figure out the full path. In the worst case, we can do n checks for each element. Let's say the array was 1. Let's say array was 1, 2, 3, 4, 5, 6. So this time, first of all, there is full loop to check each element, because even if we find a better one, let's say we have 1, 2, 3, 4. Even if we find 1, 2, 3, 4 here, we still, for this number, we check if there is 3, 4 or not. Because this is the extreme brute force, we do not care about if we have solved something better already before or not. So this is the array. So we will do one loop over the full array, assuming that each element is the first element. Now for each element, we do total of n loops. Like for 6, we will do one loop to find, okay, not for this actually. When the I reaches here, so for 1, we find 2, one loop. We find 3, one loop again. We find 4, one loop. 5, one loop. 6, one loop. So in the worst case, for this, for one element, we will do n checks. This function check I plus 1, let's say, it will be called n times. So that means again n. Now this function is calling n times, and this function also does one loop over the full array. So this is also O of n. So again n here. So this is the time complexity O of n cube in the worst case, if the full array is a sequence. So this is the time, and space was nothing because we did not take any extra space. So obviously this is not an optimal solution. We have to find something better to solve it in less time as possible. So let's have the next approach. As usual, when nothing is working out, try sorting stuff, and maybe that can help. So we will take the same array again, which is 100, 4, 200, 1, 3, 2. So why not sort this array? After sorting, we will get 1, 2, 3, 4, 100, 200. Now we can see simply all the sequences are together. Let's say if it was 101, so now 101 is here. That means one sequence here, one sequence here. We just do one loop. 1, 2, 3, 4. We got 4. 100. So this is stopped because we did not find any 5. There should be 5 here. If there's not, that means this sequence is done. So we store 4. Now we start again. 1, 2. So we got 2, but it's not better than 4. So this is the final answer. So we were able to do it in O of n log n time to sort the array, and O of 1 space. It is way better than the previous solution, which is n cube. But let's be a bit more greedy. Why is there a log n here? Let's try to do this in one loop only. And space is O1, we can do the time space trade-off. We can try to remove this, and in return we will get some space, which is okay. So let's try the final approach, which is the optimal approach for this problem. As we saw already that in this number we are checking multiple times, even though we have done the same check earlier. So what if there was some way to remember the stuff we have seen? Let's say again the array is 100. Now let me take another example for better explanation. Let's say the array is 0372, 0372 and 584601, 584601. Okay, so now we have to find the full sequence. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 digit array, but actually the answer will be 9 because 0 is 2 times when the rest, each element is 1. 0, 1, 2, 3, 4, 5, 6, 7, 8. So 9 digit array is the answer. Let's see if we can get that or not using this optimal approach. So what we want is, we have to do it in O of n. This is a target. That means we can only loop again and again, but not too many times, like max 2 or 3 loops. So what we'll do is use a set to store the elements we have seen so far. So in the one loop, we will do the full loop and add each element to the set. So the set we got is 0, 3, 7, 2, 5, 8, 4, 6, 0 not repeat because 0 is already here, and 1. Because earlier we were doing the check function which was checking the full array again and again to just find one element. As array does not give us this functionality in which we can just ask, let's say if 4 is an array or not. To check this, we have to do it on. But set gives us this in O of 1. We can just we can just ask the set if this element exists or not. So now we have this set. That means we can get in O1 each element's existence as true or false. So now we assume we do another loop. We are at 0. Now we ask, is there a -1 in the set? That means this is not the valid starting index. So we don't check every index, we only check the valid starting index. We go to 0. Now we ask, is there -1? There is no -1. That means 0 is valid. So now we start the loop from here. and we ask is 1 there, 1 is there, true. Now we ask is 2 there, 2, and we keep doing the count plus plus, because as we are seeing elements, we are increasing the length of sequence. We are seeing right now 2 is here. Okay, let's check 3 is here, 4 is here, 5 6 7 8. So we got 9. This is the answer so far, and now we check for next element. Now we go to 3. We saw that 3, we ask is 3 a valid index that can start the sequence. So we ask is 2 in the array or not. So we ask the set is 2 is there, so it says true. That means this is not a valid index, so we skip it. Now 7 can or cannot be the starting point of a sequence. So we ask is 6 there. If 6 is there, that means 7 is not valid. We have to start from 6 to get the longer answer. So we ask the set is the 6 there. It says yes, 6 is there. So we skip this again. Now we go to 2. We ask 1 is there or not. 1 is there, so skip. For 5 we ask 4 is there, so skip. For 8 we ask 7 is there or not. 7 is here, so skip. For 4 we ask 3 is here, skip. 6 we ask for 5's existence, 5 is here, so skip. For 0 we ask -1, which is not in the array. So now this is a valid. So we again, and now as 0 minus 1 was not here, so now we check 0 plus 1 and start the building sequence from here. So we got 1 here, 1 is here. Now we ask for 2 is here. Now we ask for 3, 4, 5, 6, 7, 8. Again we got the answer as 9, and 9 was already there, so 9 says 9, nothing happens. For 1 we ask is 0 in the set or not. We found 0. That means 1 is not valid. So now the array is done, and now we got the answer as 9. In two loops, in one loop we build a set, and in another loop we do another. We check for each element and assume that we don't assume. We prove if that is a valid starting index. Then only we ask the set in one loop how much will be the full sequence. So this was O of n time and O of n space, because we just extra set, so extra space is used, and we just did 2 loops, so this one is fine. We do the set loops sometime, but this is not much, because at max it will be 2 to 3 times, because in this array we saw there were 10 elements, but we only did the loop 2 times because there are 2 starting valid points. In the previous question we did check for each element. There are 6 elements, and we did n checks for each element, so that was too much time complexity. So that's it for today. Thanks for watching, and I'll see you next time.